Now, we are going to solve example 2. Please read the question carefully. To show that f(x) is a one-to-one function, we have to start with f of x1 is equal to f of x2, substitute x1 or x2 to the corresponding functions. Next, we eliminate 3 on both sides. Next, we eliminate the exponent and we will get x1 minus 1 equals to x2 minus 1. Eliminate negative 1 on both sides of the equation, and we will get x1 equals to x2. Therefore, we have shown that f(x) is a one-to-one function. To find the inverse function of f(x), we have to start with the composite function between the function and its inverse. F of f inverse is equal to x. Then, substitute x in the function to become f inverse x. Bring 3 to the other side. The equation on the right-hand side will become x minus 3. We apply natural log on both sides of the equation because we want to change natural log of e to become 1. We will get f inverse of x minus 1 equal to natural log of x minus 3. Finally, we will get f inverse x equal to 1 plus natural log of x minus 3. To find the domain of f inverse, we have to consider the term in log. The term should always be positive. So we write it as x minus 3 is greater than 0, simplify, and we will get x is greater than 3. The domain of f inverse will be the same as the range of f. X greater than 3 can also be written as an open interval from 3 to infinity. To find the range of an inverse function, we need to know the type of function we are dealing with. For a logarithmic function, the range should be real number. So, the range of the inverse function is the same as the domain of the function, which is real number. Now, we are going to sketch the inverse logarithmic function, using xy Untitled method. Observe the logarithmic function. If x is positive, and y is positive, this means that we have to sketch the function starting from the first quadrant. Note that a logarithmic function has an x-intercept. So we have to find the x-intercept. To sketch the function, x-intercept exists when y equals to 0. We substitute y equals to 0 into the logarithmic function. We then bring 1 to the right-hand side. We change the logarithmic into exponential equation. Finally, we get x equals to 3.4. This is the x-intercept. Next is to find the vertical asymptote. To find the vertical asymptote, we have to observe the domain. As previously taught, to find the domain of a logarithmic function, we have to use the term inside the log, which is greater than 0. This means x minus 3 is greater than 0. The domain will be x greater than 3. This means the vertical asymptote is x equal to 3. To sketch the function, and its inverse, on the same coordinate system, I choose to sketch the inverse function first. To sketch the inverse logarithmic function, start sketching from the first quadrant, approaching and passing through the x-intercept of 3.4, and approaching the vertical asymptote of x equals to 3, closely but not touching it. I will sketch the exponential function later, by using the reflection on the line y equals to x. Next, sketch the horizontal asymptote for the exponential function. Finally, sketch the exponential function, starting from the first quadrant, approaching and passing through the y-intercept of 3.4, and approaching the horizontal asymptote of y equals to 3, closely but not touching it. Fx and f inverse x are inverses of each other. Fx is a reflection of f inverse x at the line y equals to x. For question 2b, we want to determine whether the logarithmic function is a one-to-one function. It is known that a function is a one-to-one function if f of x1 is equal to f of x2. Substitute x1 for x on the left-hand side and x2 for x on the right-hand side. Eliminate negative 1 on both sides. We now have only logarithmic terms. We then eliminate the logarithmic terms on both sides. We are left with 2x1 minus 1 equals to 2x2 minus 1. We again eliminate negative 1 on both sides. We will get 2x1 equals to 2x2. Finally, we will get x1 equals to x2. Therefore, the logarithmic function is a one-to-one function. Next, we are going to determine the inverse for the given logarithmic function. We start by using the composite of f inverse equals to x. We substitute the x in the logarithmic function with f inverse of x. We bring -1 to the right-hand side. The equation on the right-hand side will become x plus 1. Next, we change from a logarithmic to exponential function. Finally, we get the f inverse equals to 3 to the power of x plus 1 divide by 2. To find the domain of the inverse, we observe the inverse function itself. The inverse is an exponential function. For an exponential function, the domain will be real number. Next is to find the range for the inverse function. Range of the inverse function will be the same as the domain of the function itself. If you look at the function, which is a logarithmic function, for the domain of the function, we consider the term in log will always be positive. It can be written as 2x minus 1 is greater than 0. Bring -1 to the right-hand side to become 1. Finally, we will get the domain x greater than half. Now, we are going to sketch the function and its inverse on the same coordinate system. I want to sketch the logarithmic function first. We will be using xy Asymptote method. Consider the logarithmic function. When x is positive, y is also positive. So the function is sketched from the first quadrant. A logarithmic function has an x-intercept. X-intercept exists when y equals to 0. We substitute y equals to 0 into the logarithmic equation. We bring -1 to the left-hand side, change from log to exponent. Finally, we get x equals to 2. This is the x-intercept. Next is to find the vertical asymptote. To find the vertical asymptote, we have to consider the domain of the logarithmic function. To find the domain, the term in log, 2x minus 1, should be greater than 0. The domain will be x is greater than half. The vertical asymptote is x equal to 1 over 2. To sketch the logarithmic function, we start sketching from the first quadrant, approaching and passing through the x-intercept of 2. The function then approaches closely to the vertical asymptote, x equals to 1 over 2, but does not touch it. Then, we sketch the line y equals to x. This is the sketching of the horizontal asymptote. It is a reflection of the vertical asymptote at the line y equals to x. Finally, we sketch the exponential function starting from the first quadrant. The function approaches and passes through the y-intercept of 2. Then, the function approaches the horizontal asymptote of y equals to 1 over 2, closely, but does not touch the line. F inverse x and fx are inverses of each other. F inverse x is a reflection of fx at the line y equals to x.